All right, good evening, everyone. Today we'll be continuing with our discussion on function calling. And as usual, I'll ask if anyone would like to give us a recap of what we did in the last class. Anyone? Am I audible?
Yes, you're audible.
Okay. All right. No one? Okay. I'll just do that myself then. So a message. Okay, go ahead, type Adobe. I'll read out what you type. While we're waiting for Adobe's message, we'll just continue. Today we'll continue from um, with function calling, and primarily we're going to be looking at how to create functions and expose them. Actually, them is actually bind them to an LLM so that the LLM knows um, that it has those functions, those tools available, and it also knows how to um, in what situations it should invoke those tools and how it to do that. Well, Adobe, your message hasn't come in, so I guess I'll just go ahead. The the main part of the last class that I would like us to refresh our memories about is the function calling flow. Excuse me. So this was what we looked at when we talked about function calling flow in the last class. But the truth is that this is only half of the story. There are primarily two phases to function calling flow. And um, this is the first phase, essentially. So I'll skip to where I have the two phases, and that's where we're continuing today. So in the full function calling workflow, there are two phases. Oh, the planning phase and the execution phase. I need to quickly fix that. Just a moment. Phase and execution phase. Okay. Okay, can you Can you see my screen now?
Yes.
Okay. So the two phases are the planning phase and the execution phase. The planning phase is essentially what we looked at on Tuesday. You provide the LLM with a prompt, it reasons and tries to decipher whether or not a tool call or a function call is the same thing, is necessary. And if it determines that it's necessary to call a function, it generates a tool call request. We saw an example of what it looks like. That's what the tool call request looks like. It's a JSON array. Just hold it in your mind. Why is it a JSON array? Why is it not just it's just a JSON object? Given that, I mean, it's an array of objects. Why an array? We'll see why as we proceed. Now, when the model makes that tool call request by generating that JSON array, obtaining the name of the function or tool and its the arguments that should be used in calling it. It's now left for your code. We called it the environment. We called it the execution mechanism in the environment in the last class. So it's left for your code to execute that function. So this function whose name the LLM provided, using this example, that would be get current weather. Your code will execute it with the arguments New York City for location and Celsius for unit. Now, when your code executes that function, the function generates an output. And your code needs to provide that output to the LLM, and the LLM will process that output and generate a final response. That's for a simple function calling workflow. But it's also possible that at this point of processing, that the LLM may determine that it's necessary to make another tool call. So you would go ahead to make that other tool call. That means we go back in the cycle, back here, tool call request. And when it makes that tool call request, your code will also have to execute that new tool call request, get the output of the tool, pass it back to the LLM, and the LLM will process it. And it will continue on in this cycle until the LLM determines that it doesn't need to make any further tool calls. And then it processes whatever data it got from the tools and outputs the final response. Does anybody have any question on what I've described so far today? Yes, Adobe, go ahead, please.
Can you go through the execution phase once again?
Okay. See that. Once the model makes the tool call request by generating a JSON array similar to this, which may contain more than one JSON objects, as the case may be, but for simplicity, just one JSON object. Once the model generates this output, the tool call request, your code, you have to implement code that would pull that. That means when you're building your application, your agent, as the case may be, you will need to implement code that once the LLM produces a tool call request, your code will pass that JSON array that represents the tool call request. The code will pass that array, extract the name of the function, extract the required arguments and then call that function with those arguments that are contained in the tool call request. And when the function is called, the function will have an output. Well, typically the function may have an output, but some functions don't have outputs. But I mean, if it's a function that is meant to be a tool in an agentic workflow and a tool for an agent, then it should have an output. Because if for no other reason, just to inform the LLM that it has successfully carried out whatever action the function is supposed to form. And then that output, your code passes it to the LLM, which processes that output. And based on whatever it processes, it may determine that it's necessary to make another tool call request, maybe to the same tool, maybe to a different tool. So it will continue in that cycle of tool call requests from the LLM. Your codex processes that tool call request and executes the function and passes the output of the function to the LLM. It will continue in that cycle until the LLM determines that it's not necessary to make any further tool call requests, and then it will just provide the final answer, final response to you. Okay. From your thumbs up, I take it that your question is answered. So does anybody have any further questions, or do we proceed? You're welcome. Do we move ahead? Lara, why do you have a question?
Okay, sir. I not a question, but I want to just try to explain what you have said to be sure that I understand it. So, like, there are two phases here: the planning and execution. And that the planning is when there's a user prompt, then being the reasoning faculty here will decide if there's a need for any function or tool to be called, and if yes, it will call that that tool. That's about the planning. That's the plan. So the second phase is execution.
It actually makes a tool call request. It doesn't really call the tool. It is your code that will call the tool. The tool in this case is a function.
Oh yes, sir. Yes, sir. So it will place a request for the tool to be called. So when then this in the execution phase here, the first level there, execute function, that means the tool was called, then the output of the function is now passed to the LLM back. And so it will again reason if there's a need to call another tool. If yes, it will go in that cycle until there's no other need for anything, then give you a response. So as an addendum to that question, sir, I just wondering, that's not my original question, is that if there were many, or if there's a need to call many tools, would they not be concurrent, considering latency or delay in giving the final output?
It's something we are going to address further in today's class. So I would say let's keep that pending.
Okay, sir.
Right. If it turns out that by the time we're rounding off, your question isn't answered, please pull it up, then I'll answer. But I'm sure that it's part of what I'm supposed to answer in this class. Yes, Adobe, go ahead, please.
Yeah, his question spawned another question. Sorry about my background. It's kind of noisy. I'm sorry about that.
It's okay.
So, I'd like to know, like, from what I'm seeing here, it looks like the LLM is like, to a layman, LLM is like a middleman because it makes a request and it also provides a response, right?
Yeah, the thing is, if you remember, we said that, well, that's the fact. LLMs are text-based, right? So all the LLM really does is that it predicts the next token. It generates text. You provide an input, it generates the next token, and it will keep generating a sequence of tokens until it predicts that that's the end of the token, and it gives you that output. That's what the LLM does. It cannot execute code. So the the function calling workflow, when you make a request that requires a function to be called, the LLM cannot call the function. It can't execute code. All it can do is to generate text. And the text it generates in this case, when it determines that there's need to call a function, is the tool call request, a JSON array like this. Now it's you who are building the agent. You would need to, as part of your development, implement codes that would pick up this array, pass it, extract the name of the tool and the arguments with which it's supposed to be called. These would have been provided by the LLM in the tool call request. And that your code will now go ahead to execute the tool, to execute the function, pick the function's output and provide it back to the LLM. Per your request to call this tool, I've called the tool and this is the response from the tool. Then the LLM goes ahead, thinks about the response it got and figures out if that satisfies, if that's enough for it to satisfy the intent in your prompt. It gives you the final response. But if it determines that for it to satisfy the intent, it needs to make further further tool calls are needed. It will also make further tool call requests. And for each tool call request, your code should execute the function and pass the function's output back to the LLM for further processing. Does that okay?
So yeah, so if I'm providing the LLM is like in between the chain of communication using two call tools, two call requests or whatever. What I'm trying to understand is anything that is required, the LLM will go and check for that and say, oh, they need this, can you provide that? Then when it gets that, it checks if it contains everything that is required. Then if it works, then the LLM can now display the response for me to see. Is that correct?
Exactly.
Thank you, sir.
You're welcome. Any other question from anyone else? All right, then. So we'll move ahead. Now, we'll look at the best practices for defining tools. If you recall, when we talked about defining or declaring tools earlier, we said that there are three key things to provide, namely the name of the tool, its description, and the schema of its parameters. So now we want to look at the best practices for defining these tools. Firstly, what I've tried to do here is to provide like a preamble, like a context, that tools are primarily their external capabilities. Some people call them skills, right? The external capabilities that the LLM can use, like APIs, retrieving information from databases, and so on, right? So, and that apart from the LLM, tools form the core of AI agents. So that for that agency, the two major components that form that agency or that give that agency capacity are the LLM, which is the reasoning core, and tools which allow it to execute actions, which allow it to take actions, which allow it to interact with its environment. So tools, they augment the LLM's capabilities. They a way of, like we said in the first class, bridging its limitations. Limitations like lack of real-time data. LLMs don't have access to real-time data on their own. All they have is the data that was used to train them. And typically that data is stale because by the time you're using the LLM, maybe it was definitely most likely wasn't trained with data that was just generated today. So it's trained with historical data, so it doesn't have the capability of providing you with real-time data, and it doesn't have the capability of performing external actions like switch on, turn on your lights, write some data to a database, and so on. Now, okay, Kenneth, is it possible I just finish? Is it possible I just finish explaining so that I don't lose track of my thoughts? Okay. So, because of the importance of a tool, its description, well, tools are important, but you also need to understand that the primary guide that the LLM has on how to use the tool, on what the tool is for, on which scenarios the tool would be beneficial in, is the description of that tool. And so it's important for you to be detailed in your description of the tool when you're defining the tool. Your description should be clear and detailed, and it should include side effects of the tool. It should cover the return formats of that tool. It should cover the use cases of that tool as much as possible. Of course, it's really context dependent, but the more detailed you are, the more reliably the LLM can use that tool. First of all, if it doesn't know that that tool is available to it, it definitely will not use the tool. If it knows that the tool is available to it, but it doesn't know what the tool is used for, it wouldn't know when to use the tool. Okay, if it knows what the tool is used for and knows when to use the tool, but it doesn't know how to call the tool, then it can say, yes, this tool is appropriate, but how does it can't format the tool call request. So it's important for the tool description to be detailed when you are defining a tool. Yes, please go ahead with your question.
Okay, sir. So can you hear me now?
Yes, I can hear you, even though it's skipping a bit.
Oh man. Okay, so based on what we have like discussed so far, I have come to the thought that the LLM is the brain and the tool is a
Yes, you're muted. The last part I heard was that the LLM is the brain and the tool is. I didn't hear anything after that one. But
LLM. So this is my thoughts that I have formed throughout this section, and like you could correct.
okay, Kenneth, is it possible that you is it possible that you send your question in the chat?
Would let him know whether if
Just type your question in the chat. Okay.
I can know like
Okay, while we are waiting for Kenneth to type his question, does anyone else have a question? Okay, no one. So I guess we'll just push on pending when Kenneth's question comes in. And we might just reverse a little to, if necessary, to address it, and then we'll continue. Now, there are some concepts that I think are helpful for us to look at, some concepts around tool use. Okay, Adobe, you want to say something? Please go ahead.
Yes, please, can you go back to the previous slide?
And you see it now?
Not yet. I don't know if it's for me. Okay, I can see it now. The last 2 points, two descriptions with the verbals. I'm not sure I get what you mean by that. And then the last one says they should clear and detailed description. That element is not clear. I don't know if it's missing anything.
Yeah,
Okay,
it's
they should be
missing. I
clear,
think
right?
there's a word missing.
All
No,
right.
it should be that they should provide or contain clear and detailed descriptions of
Okay.
something is missing there.
Okay. So, how about two descriptions with the verbals? What do you mean by that?
Essentially, you should be detailed, not they shouldn't be brief, because when you
As much as you can.
try to make them, you shouldn't make them overly verbose, but the point is be as detailed as it makes sense. If
Possible. Okay.
brevity is not a good thing in this case, because when you try to be brief, you may not provide adequate context for the LLM to really understand how and when to use the tool. So detail is important for the tool descriptions.
All right, thank you.
Okay, you're welcome. Kenneth has typed his question and he says, so in the nutshell, the LLM is the brain and the tools add up other functionalities limited to the, I wouldn't say functionalities limited to the LLM. I would say functionalities that are beyond the capabilities of the LLM. So those functionalities that are beyond the LLM capabilities are its limitations. It's just like the LLM is the brain, the tools are the hands that allow the agent to do something. The LLM is the brain that controls the entire agent. I think that would be a fair analogy. Okay, so some tool use concepts. The first we'll look at is parallel versus sequential tool calls. Olarewaju, you asked a question earlier about what if there's need to make multiple tool calls, right?
Yes, sir.
And then remember, I also talked about, I was asking it was why is the LLM's response when it makes a tool call request, why is it a JSON array? Why is it not just a JSON object? Now, it's let's assume that it needs based on the intent, the LLM determines that it needs to call this tool, but it doesn't have the user prompt or the context, whatever the context the LLM has, wherever it gets that from, whether it's from memory or wherever, does not provide a value for one or more of that tool's parameters, of that tool's arguments. And it can't make that tool call without having values for its arguments. And then there's some other tool that can provide the value of that argument. So it means that it has to call this other tool first to get the value of that argument, and then it combines that response it got from that tool with the other values that it already has in its context, and with those it requests a call to the main tool that will do what it has determined that should be done to achieve the intent in the user's prompt. And so this involves sequential tool calls where the a particular tool call requires the output of another tool call, meaning that one tool has to be called first before the other tool call. In that case, the tools have to be called sequentially. But where the tools are not related in the sense that none depends on the other, and the LLM has all the necessary context to call them, can call those tools in parallel. And that's why you have the tool request, the tool call request is a JSON array because it can contain multiple JSON objects, with each object representing the call or the request to call a particular tool. So where the LLM determines that it can call multiple tools in parallel, then there will be multiple objects within that JSON array. But where it's just going to call a tool at a time, that means if it will call multiple tools with sequential, then there will be only one object in that JSON array. Does anybody have any question about this? Okay, so we'll continue. The next concept is tool control. Now, many LLMs have the ability for you in instantiating them. Okay, Daniel, you have a question. Go ahead, please.
Yes, sorry. I think you lost me with the two use concepts, the sequential and the parallel. If you could kindly just go over again.
Okay. You have the LLM, and the user wants you to go. The user wants you to go make a table for them, a wooden table. You have a tool, a make table tool, right? So you will typically just call the make table tool and it will generate a table. But then you don't have wood. The user did not provide you with wood. And there's a get wood tool. Now, if the user had provided you with wood, you would have used that wood that was provided by the user in their prompt or whatever you get from your context, maybe memory or wherever. You would have simply called the make table tool using the wood that you have. But given that you don't have wood, and for you to call the make table tool, you need to have wood, you would need to first of all call the get wood tool, and the output of that tool which you get will be the wood. And with that wood, you'll now call the make table tool. In that case, you're calling them one after the other. That is sequential tool calls. But let's consider another scenario that the user is asking you, turn on the coffee machine and turn off the television. Two different actions. You don't need the coffee machine to be off to be on before the television goes, or you don't need the coffee machine to be on before the television goes off. Nor do you need the television to go off before the coffee machine goes on, except maybe there's an exceptional case where maybe, I don't know, maybe because of power constraints, you can't run both together. So you need to turn off the TV before you turn off, you need to turn off the TV before you turn on the coffee maker. But I mean, that's part of the context. If that's the case, you would have already provided that context to the LLM. So in the case where you have two different, yes, it's necessary, the LLM, that means it's necessary to make two or more different tool calls, and none of these two calls depends on the other, then it calls them in parallel, calls them all together, in which case the two call requests would have multiple JSON objects within that JSON array. Each JSON object represents a tool call request. It contains the name of the tool and the parameters that are used to call that tool. Does that answer your question?
Very well, clearly. Thank you.
Okay. All right. So the next concept is tool control. You may be able to set how the tool or how the LLM uses a tool. And one option is author, which where you set it as author, the LLM, you said you leave the LLM to decide whether or not to use a tool, and that's the default value. So for some LLMs, they allow you to set these parameters. Where you set it as author, you've said LLM, based on the context, decide whether or not to use a tool and go ahead. The other option is none, where you're saying LLM never ever use any tool. So what you just want is pure text generation. When you ask a question or make a comment, the LLM just responds with text. It doesn't try to request any tool calls. You said never ever use tools. The third one is required. And this option means always use this particular tool. So if you set it as required, it will always use that tool. In this case, it doesn't matter whether it's a nail you want to drive in or it's a mosquito you want to kill. You've told him always use this hammer. So whatever you want to do, even if it's to wash your car, you to use the hammer when you set as required. The third concept we will talk about is, yes, Adobe in sequential. It's, well, the LLM, even if they are not dependent on one another, you can still make the call sequentially, but that is inefficient. If they are independent tools, then I mean it's more efficient to call them in parallel. Calling them sequentially means there will be more delay before the LLM can provide the final answer to the user, and that's not user friendly. Okay, so back to tool use concepts. The third one is tool orchestration frameworks, and these are just frameworks that simplify that process of passing the tool use requests output of the LLM, executing the tool, providing the functions response back to the LLM. They simplify this process. And such frameworks include LangChain, Llama Index, Crew AI, those same agent development frameworks that we talked about, was it last week or 2 weeks ago? They make it easy for you to, that part of the tool function call workflow where your code is supposed to handle, they make it easy to do that. That is, we'll be using that method in this course. And that's basically the talk that we have for today. What is left is for us to look at some code and play around with some code. So I'll just ask, does anybody have any question before we move to that?
Sir, just to put everything in perspective before we move on, sir. Please, can you go back to the previous slide, sir? Thank you, sir. So far so good. We have dealt with prompt chaining. You taught us about LCell that years ago, line chain expression language, those pipes and co, which I know is to change one output to the other. I believe that's where, of course, because I remember we did line chain, core, and the likes in that place. So is it that exact place where this orchestration happens? Because I know that's where we imported line chain, core, and prompt template, chat prompt template, and the likes. So is it that orchestration? Because I know that pipe, that vertical line that joins the output, like even our last task, that we pass the output of one to the other. Is that the orchestration, sir?
That is not tool orchestration. There was no tool involved. You are simply orchestrating an LLM. You are simply building a chain with, I think the chain was prompt template to LLM to output parser.
Yeah, output, yes.
There was no tool involved in that chain. So that's not tool orchestration. That was simply LLM orchestration, just with the added spice that it was a chain of runnables.
Okay. So anytime we need to join things together, we have to call that orchestration.
Here's what I would say. Here's what I would say, right? In the code I want us to look at, you will see there in the code I want us to look at, there is chain and there is tools. So maybe that will make it all clearer when we look at that code.
Okay, sir. But what I pick from here is that we can have LLM orchestration. We can also have tool orchestration. So what we did last time was LLM orchestration.
Tool orchestration still involves LLM orchestration because it's the LLM that requests for the tool calls. So you can't have, in the context of agentic AI, you can't have tool orchestration without LLM orchestration. I mean, LLM orchestration is its first step towards tool orchestration, since it's the LLM that requests for the tool to be called. But you don't necessarily need the tool to orchestrate an LLM. An LLM can just operate in text-only mode.
Okay.
In which case, it doesn't need any tool.
Thank you, sir.
So I'm going to stop sharing these slides, and then I'll share my ID. Okay. What I'll do before okay, let me stop sharing first. Then I think I was supposed to do this before the class, but let me do that quickly. I'm going to paste some code in the Discord channel, and that's the code that I'll be running, so that you can also follow on your system, or much later you can also have access to it. So I'm going to paste the code in the Discord channel now.
No, I can't hear him. Adobe, it's only me.
I was muted. The code is on Discord, so just look at it and pull it. Then I'll give you a few minutes and then we'll proceed. Copy the code into your own environment so that you can also execute. Have we pulled? Have we copied the code? Do we move ahead? Are we set? Still waiting for confirmation on whether we should go ahead.
I've copied.
Okay. Has anyone else copied it? You're unmuted, but I can't hear anything.
Please, can you reshare the source code? Because my network, and
So I thought the code will be pasted to the chat room.
The code is in the Discord channel. That's why I said I was going to paste it, and I've pasted it
Oh, all
since.
right. Okay, sir. I was waiting for it.
It's on Discord. I put it on Discord so that it's easy to copy and paste, because the last time that we tried to paste code in the Zoom chat, you need to do a lot of work to format it before you can execute. Yeah, so we move ahead. In the code here, essentially, I defined three tools. The first tool is get location temperature. What I try to implement here is the tool that we looked at in the two definitions that we looked at in the last class. But there they called it get to location weather or something, but I decided to be more specific, get location temperature. And the inputs are still the same location and units, with units having a default value of Celsius. That the constraint that was specified in that description, that definition rather, that the units will only have two possible values, Celsius and Fahrenheit. I implemented that as a literal. I believe I have, I think, okay, here, the temperature unit literal. Then the other two tools are get location date time, which retrieves the local time for a given location, but well, not as a given location really. It's actually more of a given time zone, and it takes the offset of that time zone from UTC as its input and returns a date time. The third one is get offset from UTC. Now, this one takes the name of the location and returns that offset, the offset of that, the location's time zone from UTC. Now, looking at these three functions and their definitions, which of these functions do you think can be called in parallel, and which of them do you think must be called sequentially? Was I audible? Can you hear me?
No, you were not. No. I can hear you now, but before now you were not audible.
I was saying, I asked a question, but did you hear my explanation about the tools?
Yeah, I did.
Okay. So I was now asking, looking at the three tools, the description of the three tools, the first being get location temperature, which returns the temperature of a given location and takes that location, which I implemented as a literal here. It takes the name of that location and the temperature unit, which is also a literal. That's the first one. The second tool being get local date time, which takes the offset, an offset from UTC for a given time zone and returns the local time in that time zone. And the third one being get offset from UTC, which retrieves that offset from UTC given a particular location. So when you give it a location, it determines the offset of that location's time zone from UTC. And I asked, given the descriptions of these three functions, these three tools, which ones do you think can be called in parallel, and which ones do you think must be called in sequence?
Hello, sir. Hello, sir.
I think he is having network issues.
Yeah, please go ahead, Daniel.
So the get location temperature, that one requires the location before it can give you an output. The get offset from UTC tool, that one also requires the location. So it looks like, location is needed for these two tools. It's only the get local date time. I think that one doesn't require any input from another tool. So I think that one can run parallel to the other ones.
Okay, so if I get you right, the get, let me open that again.
The get
The
location
get local
temperature.
date time can run in parallel with get local location temperature and can also run in parallel with get offset from UTC. Is that
Yes.
okay? Zarao, you have a different opinion. Please go ahead.
Yes, I think get location temperature can run in parallel with the get local data, while the get local data can roll in sequence with the UTC of them.
Does anyone have a different opinion from these two? Adobe, go ahead, please.
I didn't hear what they said. I had a little network issue, but I think the location must be go in sequence with the UTC because you have to get the location before you talk about the the time for that area. For example, Nigeria, you have to know it's Nigeria first before you be able to get the UTC.
But do we have any get location tool? There's no tool to get location. Now this relates to, there's no tool to get location. The location is a value that has to be provided. There's no way for there's no tool to get it. So it must be provided from the context, user prompt, memory, wherever. Now look at this, get location temperature. It requires the location and the unit of the temperature. And the unit of the temperature has a default value. So you don't necessarily need to provide that. If it's not provided, it uses the default. So get location temperature only needs the location. The get local date time requires the offset from UTC, no default. So once you have the offset from UTC, you can call get local date time. Then we have get offset from UTC, which provides that offset from UTC that get local date time requires. The implication is that if the user provides the offset from UTC and provides the location, you can run these three in parallel. But if the user does not provide the offset from UTC and maybe provides only location, then you can run get location temperature in parallel with get offset from UTC because you have what is needed to run them. But you cannot run get local date time without first running get offset from UTC. Since the user has given you location and you need offset from UTC to run get local date time, then you will run get offset from UTC first, and then whatever it returns, that's what you now use to run get local date time. So get local date time and get offset from UTC must be run in sequence. And if the user provides the offset from UTC, then you don't even need to run get offset from UTC at all because whatever it returns has been provided by the user. So in summary, get local date time and get offset from UTC must be run in sequence with get offset from UTC run first before get local date time. Get location temperature can be run in parallel with any of the other tools. Does anybody need any further clarification on this before we continue talking about this code?
Hello, sir. Please, can I say something on this, sir?
Yes, please go ahead.
For a kind of question, the way I'm reasoning around it, taking it as maybe it's a personal project. I never knew what offset from is, so I quickly Googled it. I found out it means time difference from a particular location and the UTC. So, and now I looked at it like if, for instance, I need to run the tool, I need to call the tool, then getting the offset I mean, if there's another function to get local time, then getting the offset is not something that I may know. Since it may depend on maybe daytime saving or whatever. I don't think it's something that I may know, but I may know my local time where I am. So I want to know what could be the objective of this tool calling. Is it? I know that the temperature is a basic thing that must be obtained. Then local time, we know it. Is
Have
it the
you
offset
read
as our target?
have you read the descriptions of these tools? Have you read the doc strings?
Not quite, sir.
Just take a little moment and read them.
Okay, okay, sir.
It's showing on the screen now,
Okay,
particularly get local date time.
okay, okay. Yes, I've gone through the dog string. The get
Okay.
location temperature gets the temperature in a city, and we have to provide the location before it
Okay.
will fetch then the local
So
time.
so get local date time is not for your own local time. It's for the local time at any time zone. It's flexible. So when you provide it with a time zone, it gives you the local time in that time zone. So
Oh,
it's like something that you can use to convert time. If you know the time in UTC, then you can, what is the time in so and so time zone? What is the time in WAT? What's the time in EST? What's the time in IST? Or
yes, sir.
whichever one as the case may be. So
Yes,
that's
sir.
why you're providing the offset. That offset is the offset from UTC, which is actually what is used to specify a time zone. This time zone is specified by how well, apart from the longitude, it's essentially what is the offset of its local time from UTC.
Okay.
So, okay, let's continue. Okay. Let's continue. Let's continue. Maybe that will make these things a bit clearer. Now, how do we these tools are functions, right? But what makes them tools is because we are using the tool decorator on them, on the function definition. And that's actually a design pattern, the decorator pattern. We are using the tool decorator on these functions, and that's what makes them tools. It gives them certain properties. There are two ways to define tools. One is as a class, and one is as a function. This with this decorator, and this is a simpler definition. Just define the function and give it the decorator. It becomes a tool, a LangChain tool. And we import that from LangChain.tools. We import tool. It's a decorator that can make any function to act as a LangChain tool. Now let's look at the system prompt template. Here it says you're a helpful assistant. You have access to the following tools, and there's a placeholder for tools. Whenever the user asks for weather or time-related information, you retrieve that information from the relevant tool and provide the user with the retrieved information. If the user requests for the time in a given location, you should first of all retrieve the location's offset from UTC and subsequently use the retrieved offset in retrieving the local time in that location. Now, ordinarily, because we are going to provide the description of the tools to the LLM, it should be able to know what to do without this. But because these are small models and they can fail more easily, that's why I still provided this in the instruction as a form of behavior well, sort of soft behavior guardrail, right? And now I specify the parameters to define the model name, temperature. Of course, I talked about the temperature unit literal and the location literal. Here, I try to pick locations from around Africa, East Africa, West Africa, South Africa, and North Africa. I also try to ensure that there are different values of time offsets. There are offsets of 0, there are offsets 0 hour, 1 hour, 2 hours, 3 hours, and -1 hour. I think there's only one place in Africa that has a -1 hour offset from UTC, and that's Cape Verde. Now, we've already looked at the two definitions. These are just helper functions. Generate temperature simply generates a random floating point, a random float between the minimum temperature value and maximum temperature value that you provided. And well, it's just to simulate, just to help us simulate an API that retrieves the temperature of a place when we call gets location temperature. And then we have this get tools info helper function that extracts the name and description of the tool, enabling us to fill this tool's placeholder in the system message prompt template. Then we also have this third helper, generate prompt to runnable chain. This is the one that builds the chain. In this chain, we don't have an output parser. I did that intentionally because I want you to see the raw output of the LLM. But typically, I would put an output parser in the chain so that it reduces the work for me, because without the output parser, you would need to extract the output, the useful part in quotes of the output. But then too, when we do this in an actual agent orchestration workflow, we don't really need to do that, but we are not getting to that yet. It will still be a couple of classes before we get to that. Now, what we want to focus on is just on the tool calls. So we have a chain here comprising of the prompt templates and the runnable. Runnable in this case will be the LLM, but we are using a runnable here so that it can be any runnable, right? It's more like a flexible helper, but in this case, we'll just, well, not also just because of that, we'll have two different categories of model, one with the tool exposed to it and one without the tool exposed to it. The one with the tool exposed to it is no longer a simple LLM. And that's why we need to use a runnable, because a runnable is like an interface for any object that implements it should be the run, in this case, invoke method in LangChain. Now, here, I define the available tools, list those 3 tools in an iterable here in a list, and then I instantiate the prompt template from the prompt template text, instantiate the prompt template object. Now I'm using the from messages method. In this case, in the last class, we used from templates, right? But in this case, because we have a system message and we'll need to have a user message, here I used human. That's why I'm using from messages. And I still provide the different the placeholders. The system message has that placeholder of I think it was tools, And now in the human message, I just provide a placeholder input prompt, which will take whatever prompts, whatever user prompts you provide to the chain. And here is where, instantiate the LLM using chat Olama. If you're going to use Grok, what you would use would be chat Grok. And instead of importing LangChain Olama like I did here, chat Olama from LangChain Olama, you would import chat Grok from LangChain Grok if you are to use Grok model. Now, this is the version of the model that is not aware of the tools. Of course, because I mentioned the tools in the system message prompt template, it will know that there are some tools available. It doesn't know how to call those tools. But this second one, where I have LLM with tools and where I bind the tools to the LLM, it knows those tools. It can see the description of those tools. It can see the parameters of those tools, and it knows how to call the tools. Of course, when I say how to call the tools, it's really how to make the tool call request, right? So we're going to try to run two chains with the same user prompt. The first one will be with this LLM that doesn't have the tools are not bound to it, and the second one will be with the LLM that the tools are bound to it, and we'll see what the outputs will be. And we're going to use one location prior. What I would like you to do is try this out yourself after the class with different locations, try to do different modifications and see what output you get. Now, this will be a query for the weather, and the user prompt is, what's the current weather in locale? And the locale, in this case, is you provide that as prior. I think we said locale as prior, right? Yeah. So using an F string here, that means it provides that directly. And the tools, that tools placeholder, I'm replacing it with the get tools info method, they call to it, which will retrieve a dictionary, I think, of the tool name and the tool parameter schema, I think. But using JSON.doms because the placeholder is expecting a string. So I'm providing it with a JSON string. Excuse me. And the response will just say response to weather query without tool. I will provide whatever response the chain returns. And we also call the same with the same prompts, everything the same, except that this second time we're going to use the chain that with the LLM that has tools bound to it. So we're going to run this and we'll see what the outputs are. We'll compare the outputs for the LLM that doesn't have tools bound to it with the output of the LLM that has the tools bound to it. Now, Python running LangChain Running chains with Python 3.14 gives this warning. They haven't fixed it yet, so but it's really nothing to worry about. Even though if it's in production, it will be better not to use 3.14 until they fix this. It's a Pydantic compatibility issue. This takes about between 2 and 4 minutes on my computer, since I'm running Llama model, Llama 3.23b. Okay, it didn't take much time. And so here is the output. I'll just leave you to read. This is the response of the model that doesn't have tools bound to it. Just read through this, observe this. I did p-print so that we could see the entire text at once, because just prints unless I it's an object anyway. Just look at the response, and then after this, we'll look at the response of the model that has tools bound to it. Now notice that the model is not able to provide you with the temperature. Well, the weather in this case, the only value is it says that it may be able to get from the system messages the temperature, but then it doesn't know how to call the tool. It knows there's a tool. That's why it's saying that to get the weather information, temperature information, you will need to use the get location temperature tool and specify the location as prior. But if I hadn't put the tools, that tool's placeholder, it would not even know at all that there's a tool to probably maybe tell you that I don't have access to real-time weather information, but you can get the weather information by calling APIs like this and that, and so on. That's probably what to do. Or some models will just tell you, I'm a simple language model, I don't have access to real-time information and all that, right? Now let's look at the output from the model that has tools bound to it. Pay particular attention to the tool calls section of this output. The tool calls, it's a JSON array. It's a JSON array containing a JSON object representing a given tool, the name of the tool, and the args for that tool. Of course, for each, it provides an ID. But the important thing is the JSON object representing the tool. You see here, it provides the name of the tool as get location temperature, and the args location, value prior, units, value Celsius. You use the default value. So because we bound the tools to the model and we gave it the tool descriptions. Of course, binding it sees the tool descriptions, and we also helped to emphasize that in the system message, it's able to figure out that when you're asking it to give you the weather in prior, that it has a tool that can give you the temperature in prior, and it knows that tool is temperature is part of weather information. So it just makes a tool call request for weather, maybe for temperature. Well, if we continue this till the end of the workflow, we would see whether it's going to just report the temperature or it's going to tell you, okay, I'm just giving you temperature. For other aspects of weather, this is what you will do. Now, next, I want us to try another request that would require some other tool. It's just the same structure. The only thing we're changing is the exact request. And this time we'll ask for time. That should be the local time. And we'll see what the output of the chain would be. I need to uncomment that part of the code and comment this one we just ran. Okay, so this is what we want to run now. So I comment this out. Okay. So what we want to run now is we want to ask the prompt we're going to run now is what's the current time in locale? Our locale is still prior, right? Our locale is still prior. Like I said, I would like you to run this with different locales so that you see. Now, for each locale, when it's supposed to get time information, it gets the offset from this dictionary that I provided here. So I'll run this and we'll see what the response will be. We're running both with the LLM that doesn't have two bindings and with the one that has two bindings so that we can compare their outputs. My apologies, please. We have gone beyond 10 p.m. And just let's run these and compare the outputs and we'll round off. It was just because I had that break in transmission earlier. Apologies, please. Okay, here we have the output from the model without two bindings. And just read what it has. And then when we get the other response, we also look at the one with two bindings. Now notice that the model initially felt that it could execute the tools. It started talking about tools because these tools were mentioned in the system message. Like I said earlier, if we had not mentioned the tools in the system message, we wouldn't have any idea that there are any tools. But then it realizes that, hey, he doesn't know how to execute these tools. And he rambles along a bit before he finally says, okay, you should try to check online. There are websites or apps that can provide you with this, all the information that you are asking for. And now we look at the output from the model with two bindings. notice here in the to calls section that it's able to determine that it should call the get offset from UTC function. The request was the local time in prior. The function that will give that value is get local time. I think that's the name of the function. But then it requires offset from UTC. So the model is smart enough. Of course, we not really about being smart now because we gave it that specific instruction in the system message that if the user asks for time in a given location, you should first call the get offset from UTC tool and then use that to call. So it's following that instruction. And that's why it says that the first thing it should do is to call the get offset from UTC with location set up to prior, which is what it did here. Now we're going to run another set of two different calls. This time we'll try to trigger parallel two calls. So I'll comment this out and then go ahead with initiating that. So this time, the query we are going to run is, what's the current weather and time in locale? Remember, our locale is still prior. So effectively, what we're asking is, what's the current weather and time in prior? We'll ask both the model that has no true bindings and the model that has true bindings, and we'll compare their responses. Now, in this situation, the correct behavior is for the model to perform parallel two calls, since it just needs location to call the get temperature, get location temperature function tool, and then that should give the weather information. And for the time information, it needs to call get a UTC offset first. And get UTC offset and get location weather, they are independent. So it's supposed to make call them in parallel. In this case, though, I think the model will call the three tools in parallel. So it's actually really better to use a more powerful model. But let's see what exactly we get this time. For the model without tool bindings, it's essentially, okay, here is mentioning like planning the steps that are required to address the intents. It says first, you need to get the offset from UTC for prior, and it mentions the tool. And then it says use the retrieve offset to get local date time in prior after getting the offset. And it mentions the tool for getting the local date time. Then it mentions that to get the temperature, it mentions the tool that are needed. And it says here are the results. It says current weather and temperature in prior. and then it now realizes that it can't call the tools, doesn't know. But it's now giving you, it now goes ahead to hallucinate, tells you that the temperature is 23 degrees in prior and local time in prior. It doesn't know. It says probably in its training data, there is some data where there's temperature in prior mentioned as 20 degrees and it pulls that. But that's hallucination because that's not real time information. But for local daytime, it doesn't know. It just provides you with a placeholder. So essentially, it hallucinated. And it still finished by, please know that I'm a text-based as AI assistant and not have real-time access to current weather conditions, etc., etc., etc. Essentially, it hallucinated. Now, for the model that has two bindings, here are the two calls. It made parallel calls. The first one was to get location temperature, and it was correct about that with the arguments location set to prior unit set to Celsius. Another call to get offset from UTC with arguments location prior. Yeah, but it now added a third parallel to call, and that is where it's wrong now, because this third call is to get local date time, but it doesn't have the offset. So it should actually only call the two functions, get location temperature and get offset from UTC first. And after that, based on the offset it got, it uses that offset to now call get local date time. I'm sure that if we use a more powerful model that has been fine-tuned for two calls, it should make the correct decision and make the correct parallel versus sequential two call decision. Here, I'll ask whether we have any question, but before that, I want to change the location, locale to some other value that we have here. Let's pick Cairo. And while it's running, if you have any question, please go ahead and ask. And once the questions are answered, we'll call it a night.
Yes, sir. So thank you, sir. I think my own will be to definitely go through this video because there are a lot of things I need to review. I'll just maybe want to request, I hope it will be uploaded early by the team. Thank you, sir.
Okay, I think they make efforts to upload it as soon as possible. Because sometimes they have some technical hitches. That's what might delay any video. But typically they tend to upload it as soon as they don't tend not to delay unless there are some technical hitch. Okay, see the response for Cairo. It's still the same response. We set temperature to 0, so we are going to get almost the same thing. The only major difference here is that it mentioned Cairo, and is also trying to tell us, say the time offset from UTC for Cairo is -2 hours. I think that is hallucination. Cairo should be about 2 hours plus 2 hours or so. But it's saying -2 hours. Yeah, Cairo is +2 hours, but it's saying -2 hours. But the thing is, for the fact that you have mentioned tools in the system message, but you did not bind tools with the LLM, it will lead to confusion, right? So if you know that you are not binding tools to the LLM, you should not mention tools in the system message. But here I use the same system message for both. But ideally, since you have one without two bindings and one with two bindings, your system message for the model without two bindings should not mention tools. Okay, here's the response for the chain where we have the model with two bindings. It makes parallel calls. The first one to get location temperature, correct. The second one to get offset from UTC, correct. And it still makes that mistake of a third call to get local date time. Of course, this call should have been a sequential one, should have been made after the parallel call to the other two tools. I don't know says that when it's hallucinating. Now, this is why I was asking that you try to play around with these things and get familiar. Now, you're trying to get both using LangChain, building chains, tool call all together. But if you had try to familiarize yourself with building chains and LangChain, all would have focused on is tool calls. So please help me and help yourself too, and try to play around with this. Nothing is going to spoil. If you make a mistake, you get an error message, you debug and you continue. And the more you become friends with it, the easier it is and the faster we can move, and the more benefit you derive from the training. Does anybody have any question? Now, what we have done here is just the planning step of the tool call workflow, right? We are not going to go manually implementing the execution step. When we get to where we are building actual agents that will call tools, we are going to leverage on LangGraph to help us with orchestrating the tool, so it will handle that execution. Well, it will handle most of that execution step, making it easy for us to implement that step without having to manually, in quotes, go passing the tool call requests and executing the tool and passing the output, the LLM and all that. So does anyone have any question? If no question, then we'll call it a night. Okay, I think I'll take it as no question. So good night, everyone. Please remember that the assignments, the task, stage 2 task, the deadline is 11:59 p.m. on Saturday. So try to submit in time so that it can be graded and you can move to the next stage. Yes.
Sir, which Saturday is it? This next tomorrow or the upper Saturday, sir?
No, this coming Saturday, the 22nd or so.
Is it on this matter, sir? On this? Anyway, I'll check.
It seems that the time is very short for us, but I will try. We'll try.
Persons have already submitted. It's not a difficult thing. It's building on what you have already done.
Hey,
you mean that there's already assignment before today?
Yes.
Somebody else has submitted.
That assignment was actually supposed to be done last week, but
I'm not aware.
I hadn't graded you, but I put up. Okay, once you have checked if you have been promoted to stage, is it stage 3 or stage 2? You would see the assignment in LMS.
I saw my new score over 200.
Is it over 200 or over 100?
No, I have seen over 200 already.
Okay, that means it's multiple.
It's a bit some of
yes, it started to those.
So
I never knew we already having access to the new.
Once you are promoted, you can see the next task.
Yes, last time I checked, there was no task.
That means you hadn't been promoted at that time. Once you are promoted, you
I've
can
been
see the
graded
task.
but not promoted.
Okay, so probably you should be promoted the Let me find out. But everyone who had submitted as of last night was graded. So let me find out if you have all been promoted. Adobe, you want to say something?
Yeah, I just saw the promotion now.
Okay.
So it
Yes,
wasn't accessible
I've
before now.
not
I just saw the
been.
promotion now.
Adobe,
Honestly,
go
I
ahead.
didn't even know.
Yeah, I've not been. I've not been promoted, but then I can see the assignment.
If you can see the assignment, then you have been promoted. Without being promoted, you cannot see the assignment.
Maybe I
Okay,
need to refresh my page. I
Yes,
think
please
so.
do. Please do.
You might be
I
able
think
to see the
everybody
assignments.
I think everybody has been promoted. Everybody was promoted as of around 4 a.m. this morning. As of around 4 a.m., before 5 a.m. this morning, everybody had been promoted, unless it's somebody that submitted after maybe 2, 3 a.m. This morning. So you may need to refresh your LMS if you can't see that you've been promoted yet.
Sir, can I ask a question, sir, please?
Go ahead, please.
Okay, two things actually. I don't know, maybe it's a valid request or not, but I'll still make it all the same. The deadline of next tomorrow, if anything can be about to appreciate it, sir. Then secondly, as I went through the assignment now, I saw in the submission detail submit link to your Google Colab notebook. So does it mean that you can use Google Colab for this assignment and not our regular ID, PS code, and me that I'm talking about code spaces? Because I've been thinking that even what I'm trying to do, I mean, could be accessible on Google Colab. I wanted to ask, but I don't want to bring the issue of ID to this class again. I've been asking about PyCharm, VS Code, which I already set for VS Code. And even the code space I'm trying to do is a VS Code based stuff. But seeing now that, and it was going through my mind that Google Colab, I don't know, maybe it could be easy, but I'm seeing now that submitting Google Colab, I don't know, are we at liberty to do it anywhere and bring the results?
The assignment specifies that you also submit the link to a Google Colab notebook. So you can do your code wherever you want, whether it's in Google Colab or in PyCharm or whatever. But what you're submitting is a Google Colab. And of course, you should have your Colab, the code in your Colab notebook should have been executed.
You have output.
Yes,
You have
there should be
output.
output. Yes. So it may be easier for you to use Grok models there in Colab, because you may not be able to install Olama in Google Colab.
Okay.
So you probably will have to use Grok model. So instead of LangChain Olama, you'll be using LangChain Grok. And instead of Chat Olama, you'll be using Chat Grok.
Okay, sir. So it's not possible for us to use those models on the lab. They will charge, I guess.
It's not about charging. Would you be able to install Olama on Colab? We could try, but
Okay.
I don't know whether they will give that much. I don't know.
Okay. 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 This was online. Grok also is online. Am I correct, sir?
Grok is a cloud provider of yeah.
Okay. All right. Thank you, sir.
All right, you're welcome. Kenneth, are you trying to say something? Daniel, are you trying to say something?
I think I have still not been promoted, so I'm not able to access the next assignment.
What was your score? The cutoff is
The
75.
score.
If your score is not up to 75, then you have to redo the assignment.
Okay, then that will be the reason why I was 32. Okay.
I don't know if I may ask a question, sir.
Yes, you may, please.
I'm seeing define a pandatic model. I don't know. I don't know if we have had such a time in cluster.
No, we
Or
have
maybe it's
not.
something.
we have not used a financing model in class, but you can use a financing model. It's not difficult. It's just to check the
like
didactic
I was
documentation.
Asking, am I the kind of
Kenneth, we can't hear you anymore. Okay, while we're waiting for Kenneth, Olarewaji, your question about financing models.
Yes, sir.
Remember, you're supposed to already be a developer, right? A Pydantic model is just, if you just Google Pydantic,
about the kind of
the kind of what, Kenneth? You know what? Let's take these questions on the Discord channel so we can close the call. Let's take the questions in the Discord on Discord. So I'm going to stop the recording and we can continue discussing on Discord.
okay, bye-bye.
Okay, bye.